Hi everyone. Today we will be looking at the EasyPLC palletizing robot programming using a Click PLC. The EasyPLC palletizing robot will demonstrate sequencing and robot control using a PLC. This palletization process will fill a box container with 6 cans. A servo-controlled gantry robot using X and Y is used to do this operation. The complete box will then travel along to another conveyor to an unloading area. A robot will then pick up the box and place this on a pallet. We will discuss and show you how to program this EasyPLC palletizing robot machine using the 5 steps for PLC program development. This will involve all the ladder logic to load and unload using the robot simulator. This PLC simulator will show sequencing instructions. A drum instruction in the PLC will be used with events and a counter to load the box with 6 cans. Another drum instruction in the PLC, with time, will be used to unload the container onto a pallet. An automation direct Click PLC will be used for this application, but the general methods can be used for just about any PLC on the market. Serial Modbus RTU communication will be used between the machine simulator and the Click PLC. An Ethernet connection will be used with the Click programming software. Let's get started. Detailed information contained in this video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in this series as well. The first step of PLC program development is defining the task to determine what must be done. EasyPLC software suite contains this palletizing robot example in the machine simulator. This is just one of many machines that come with the software, so you can learn and develop your PLC programming skills. Start the EasyPLC machine simulator, MS. Select the Start button on the main page or select Machines from the main menu on the top of the machine simulator window. All the available machines will now be displayed. Click on the Palletization. This is the example that we will be programming. To the left of the screen, information will be displayed on how the palletizing robot needs to function. The machine simulator has a demo mode for the built-in machines. This will allow you to watch the operation of the palletizing robot. Select the demo mode. The system's objective will be to fill each container with 6 cans. To do this, use the servo-controlled gantry, the 3 conveyors, one with an encoder system to move the belt, the space needed to load the second row of cans, and the inductive presence sensors. The robot will automatically unload the boxes when the container reaches the unloading area. The EasyPLC palletizing robot demo mode on the machine simulator will show you the basics of operation. Select the Start button on the control panel to start the palletizing robot demonstration. Move around the 3D virtual environment. 3 icons on the top of the window will allow you to move around this 3D environment. The first icon is the default selection. This will enable you to move around without bumping into the components. The last icon will automatically show you around this virtual environment. The first-person mode will mimic a person in your 3D learning world. Once we have a good understanding of what must be done, we can move on to the next step in our PLC program development. We must now define the inputs and outputs for our application. The View I/O at the bottom of the machine simulator window will display the inputs and outputs required for this palletizing robot example. While still in demo mode, you can see the operation of the inputs and outputs. The EasyPLC palletizing robot example will require 15 digital outputs and 12 digital inputs. The EasyPLC Start mode will allow you to control the machining center simulator manually. This is ideal if you are unsure what output or input is doing. Select the View I/O on the bottom middle of the machine simulator window. You can manually run the machine simulator without any control or PLC connection. The right side will show you the corresponding digital inputs. You can now use Select and Start the palletizing robot digital outputs on the left side of the screen by clicking on them with the mouse. The Restart button on the bottom of the machine simulator window will reset the scene back to the start. Move around the 3D environment and ensure you know what each input and output represents. The third step is to develop a logical sequence of operation. A PLC programmer must know how everything about the sequence and operation of the machine before programming. The palletizing robot simulator is an excellent way to learn to program. Flow charts or sequence tables can be used to understand the process that needs to be controlled thoroughly. It must also answer questions like the following. What happens when electrical power and pneumatic air is lost? What happens when the input/output devices fail? Do we need redundancy? This step is where you will spend most of your time. Understanding everything about the operation will save you time. It will help prevent you from continuously rewriting the PLC program logic. Knowing all these answers to how the system is to react is vital in developing the PLC program. This does not have to be a formal document. You have to have a method to account for every condition in the machine being programmed. Our EasyPLC palletizing robot is split up into several different sections. We will walk through the logical sequence of operation. Splitting the requirements up into smaller sections will allow you to concentrate on the task and not get distracted by other parts of the program that are unrelated. Section 1. Start, Stop, Emergency Stop, Beacon Lights. If the emergency stop input is not on, the red light will flash at 1-second intervals. When the e-stop is on, it will allow the palletizing robot to start and stop the operation. The Start push button will start the machine, and the green light will be on. The Stop push button will stop the operation of the machine, and the red light will be on. Section 2. Can Creation. If switch 1 is not on, then no can is present. Turn on the can conveyor to make the cans to fill the box. This will all happen if the machine is started. Section 3. Conveyors 2 and 1. Box Creator. Both conveyors will run when the palletizing robot machine runs, and no box is detected with photocell 1 on conveyor 1. The box creator will be activated for a time duration to make a new box. The conveyors will stop when this new box is seen at photocell 1. After filling the pack with 6 cans, conveyor 1 will start and put the full package on conveyor 3. When the box leaves the photocell 1 sensor, a new box is created again. Section 4. Loading cans into the box. This section will load the cans into the box. We are using drum instruction for this operation. It uses a sequence table with events for each step. One complete pass through the drum will indicate one can get into the box. A counter is used to keep track of the number of cans and when the conveyor will need to index to the next row. Section 5. Conveyor 3 Control. When the box is full, conveyor 3 will be turned on until photocell 2 is on. This indicates that it has reached the unloading area. Section 6, Robot to load the pallet. A robot will be controlled at the unload area with another drum instruction. This drum will use time events to move to the next step. These are pre-programmed steps in the robot that get triggered by the PLC output. Section 7, Full box on pallet destructor. The cans will disappear when the full box of cans is placed on the pallet, and the robot moves back to the home position. This will allow additional packages to be palletized. A PLC programmer must know how everything about the sequence and operation of the machine before programming. Ask questions or view existing documentation to ensure that you know the logical steps to the machine operation. Writing out what is supposed to happen will help to clarify what is required in the PLC program. This is just another method like flow charts and sequence tables. Using the information from the previous step, we can now program our Click PLC. The Click PLC series will take you through installing the program, communicating to the controller instructions, and addressing the controller. Select the COM port setup under the PLC on the main menu. You can also call the specific communication ports by selecting them in the CPU configuration on the Function tab. Select the Setup button under Port 2. You will notice that the port assignments are printed on the PLC itself. A picture of the CPU module is also shown. In the COM port setup details window, we will leave everything as their default. The important items to note are the node address, baud rate, parity, stop bits, and communication data bits. We will need this information to connect to our EasyPLC machine simulator. Select port 1. This will display our Ethernet port setup on the Click PLC. Use a static IP address that is appropriate for your network. Select OK. We have our communication ports set. Let's now look at the ladder logic programming of each section. We will monitor the machine simulator so you can see the ladder logic function as we look at the code. Here is the logic for section 1. An internal start bit, C1, is used to control the rest of the logic. As you can see, the red beacon light is flashing, indicating that the emergency stop button is not satisfied. Selecting the emergency stop button will then make the red beacon light on all of the time. The start and stop buttons are used to control our internal start bit and lights. Section 2 will control the can creator. The cans are created when the internal start bit is on and switch 1 signal is not on. This will then turn on the can work part creator. Once a can is at switch 1, the conveyor will stop. Section 3 will control conveyors 2 and 1. It will also control the box work part creator. A timer is used for the box creator as a one-shot of 1 second. Section 4 will control the can pick and place. This is controlled using an event drum instruction. The drum enabled is done with the start internal bit. Resetting the drum is accomplished with the first scan of the PLC or by each pass of the drum instruction. This means that one sequence through the drum will put one can into the box. The drum events are controlled through a subroutine called drum event triggers. This subroutine will control the individual bits C10 to C17. The drum event trigger bit is controlled by individual bits for that step. A timer is also used to allow the axis movement to happen. A counter is used for the event drum instruction. This will count the number of cans in the box to determine if it is full. The counter is also used to determine the position to place the can into the box. Unload position 1 will happen at counter values 0 and 3. Position 2 will happen at counter values 1 and 4. Unload position 3 will happen at counter values 2 and 5. The conveyor encoder's advanced output will allow us to move to the second row in the box. When the current can position is 3 on the counter, the conveyor will advance output will be on for 1 second. Section 5 will control conveyor 3. When we have a full box, the counter bit will be on. If there is no box at photocell 2, then conveyor 3 will be on until the full box reaches photocell 2. A time-based drum instruction is used in section 6. This will make the robot pick up the full box of cans and place them on the pallet. C7 and C1 are internal bits used to enable the drum instruction. The drum instruction is reset when it performs the sequence of events once. The timing of the sequence can be seen in the drum instruction itself. Section 7 is used to make the full box disappear on the pallet. This will allow the machine to load another box. When the robot drum sequence is not running, the work part destructor output is turned on. Our ladder logic program is complete. Step 5 is to test the program. We will use Modbus RTU on our Click PLC to communicate to the EasyPLC machine simulator. Call up the palletization robot in start mode. The status of the machine simulator will be along the bottom of the screen. Currently, we have no PLC connected. Select I/O drivers on the bottom middle of the screen. The EasyPLC driver is selected by default. Under the driver pull-down menu, select Modbus driver. This driver will communicate Modbus TCP, Ethernet, and Modbus RTU, serial. Select the down arrow on the driver's name. Select the Configure button. We can now enter the information for our Modbus RTU driver. Select serial RS-232. This means the computer's COM port will communicate to the PLC. To determine the COM port number, call up the device manager on your Windows computer. Type in the serial port configuration to the same parameters that we have set in the Click PLC. The EasyPLC will be the Modbus master, client, to the Click PLC Modbus slave, server. The digital inputs from MS to the Click PLC will be C101 to C131. This will start at address 16,484 due to the offset of 1. Digital outputs from MS to the Click PLC will be C201 to C231. This will start at address 16,584 due to the offset of 1. Ensure that we have the number of inputs and outputs addresses for our application. This has been set for more in our application. We are not using any analog inputs and outputs for the palletizing robot program. Select the OK button. You will now see the inputs and outputs specified for the Modbus driver. We can manually assign the driver outputs to the PLC inputs and the driver inputs to the PLC outputs. However, the automatic assignment works well and will save you time. Select Automatic Assignment from the driver option in the main menu. This will automatically assign the PLC I/O to the machine simulator I/O. Select Start Driver and exit from the main menu. On the bottom left side of the window, you will see that the driver communicates to the PLC by the green light. Select View I/O to know the input and output status of the machine simulator. Ensure that the PLC is in run mode. we can see the operation of our EasyPLC palletizing robot program. Move around this 3D environment and ensure that the program is functioning correctly. This is where you can troubleshoot and correct errors in your program. Using the Data View window of the Click PLC programming software, we can also watch the inputs and output operations. If your program works correctly, it's time to move on. If not, you'll need to debug. This can be as simple as re-downloading and re-uploading your program, or as complicated as redesigning your logic altogether. When using EasyPLC, debugging is quickly done with no damage to any equipment. You may modify your logic several times before you get everything right. That's okay, it's all part of learning. You can practice your modification and debug by modifying the palletizing robot in the following way. Add a reset button on the control panel. This will let the PLC know that all of the boxes and cans have been removed from the conveyors. Let me know how you make out in the comments below. The basic operation of the machine works, however, we did discover an error that does exist. Can you find it? Comment below. If you enjoyed this video, please hit the like button below. I really hope that you liked it. If you have any questions about this video, please leave a comment below and I'll do my best to answer it. If you want more information about us, or you want to get our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you can get more videos like this in the future. Remember to hit the bell beside your subscription to receive the notifications. Thank you so much for watching. I'll see you next time. Stay safe.